This is a presentation on the binary number system. You're used to the decimal number system where all of the numbers are made up from 10 digits. No matter what number you have, it's made up of one or more of these 10 digits. But there's another very important aspect to the decimal number system. Whenever you have a number, each digit is in a column. And those columns are worth more depending on how far to the left you go. So the first column is worth 1. The second column is worth 10. The third column is worth 100. The fourth column is worth 1,000, and so on. Each column is 10 times greater than the column to the right. So if we had a number 3212, that would be 3 times 1,000, 1, 2, 3 thousandths, 2 times 100, 1, 2, 1 time a 10, and 2 times a 1. You add those all up, and that gives you the total 3212. So this is called positional notation, and these digits are in these columns, and it tells you how valuable each digit is. Okay, so the binary number system is very similar. Binary means 2, and all binary numbers are made up from 2 digits, a 0 and a 1. That's all they have. They don't have 10 digits. Any number that you make up is going to be a combination of zeros and ones. And like the decimal system, the binary system has its numbers in columns, and those columns are worth more as you go to the left. So the first column is worth 1, the second column 2, the next column 4, the next column 8. You'll see that each column is worth 2 times more than the column to the right. Just in the decimal system, they were 10 times more. In the binary system, they're 2 times more. So if you had the binary number 1, 1, 1, 1, you'd have 1 times 8, 1 times 4, 1 times 2, and 1 times 1. You add those up, it's 15. So 1, 1, 1, 1 in binary is worth 15 in the decimal number system. Okay? Here's a little chart for counting. So I'm going to count down this column. So the first is a 0, and its value is 0. The next is 1. Its value is 1. The next is 10. Its value is 2, because you have 2 times 1 is 2. And 0 there. 11 is worth 3. 1 times 2 plus 1 times 1 is 3. Next is 100, and that's worth 4. 1 times 4 and then 2 zeros. 101 is worth 5. A 4 and a 1, and so on. So this is how you count. So counting in binary, it's 0, 1, 10, 11, 100, 101, 110, 111, 1000, and so on. Get the idea? Okay. So that's the binary number system. It's very similar to the decimal number system. It's just that it deals in 2s instead of 10s. So the question is, why does this exist? What is it used for? Why are there only 2 digits? The decimal number system has 10 digits, and a lot of people believe that that's because we have 10 fingers. We could hold up our hands and we could count, and that's how we got the decimal or 10 number system. Well, computers use the binary number system. And the reason they use it is because computers are electrical devices. Here's a little picture of a switch, and there's actually four switches. 1, 2, 3, 4. A computer, being an electrical device, can sense whether there's electricity coming through this switch or not. And it assigns it a 1 if there is electricity going through, and a 0 if electricity is not going through. So your switches are either on or off, and you can use a binary number, a 0 and a 1, to represent whether it's on or off. So, for example, if switch 4 was on, your number would be 0, 0, 0, 1, meaning switches 1, 2, and 3 are off, switch 4 is on. If your binary number was 1001, that would mean that the first switch is on, second and third are off, and the fourth switch is on. 1, 0, 0, 1. Okay, so that's the binary number system, and computers use it and other electrical devices use it. And we'll see later that they can use these electrical pulses to do things like addition and subtraction and all kinds of other activities.